Hello, everyone. Welcome to the lecture on unsupervised learning. This is a lecture from our lecture series on applied machine learning. So, in the previous lecture, we saw introduction to supervised learning. Today, we'll talk about unsupervised learning in brief. I'll give you an overview of the algorithms, and then we'll continue with the detailed algorithms. A little introduction about myself. I work on reinforcement learning. If you want to see my work profile, you can visit this link and see what kind of projects I am working on. And rest is details. I think you can read it. I'm currently working at EY India, and I work on optimal hedging using reinforcement learning. And I have received several awards. I've also worked on Sony AI, and we are running a very large AI community in India, which is named Think AI. You can join us through this link. We are available on several social media platforms. We are highly active on our WhatsApp channel and the YouTube channel. You can subscribe us on both of the platforms using these QR codes. You can just scan this QR code and join us on WhatsApp on the YouTube. Okay, so we are regularly posting lectures on machine learning, AI, Gen AI, and or related fields. And here we are sharing all relevant information on AI. So whether it is how a company is leveraging AI to do the innovation, how the different papers are coming, and how is it that the students or the professionals can start learning AI. So there are so many things that community members are doing. So one student from MSIT Delhi secured All India rank of 11 from GATE in GATE 2024. Amulya secured research associate position at IIIT Delhi, and many paper publications, best demos, masters, and so many other stories as well. So if you also want to communicate and the network with the similar individuals who are learning AI, who want to start doing something in AI, then join our community and we'll see how is it that we can help you. So, so in this community, you will get several mentors. These mentors are experts of their field in computer vision, NLP, embedded systems, machine learning, AI, right? So they are from top organizations all over the world, and they are here to help you start a career in AI. So in today's talk, we'll be seeing a little introduction about machine learning that we have already seen in the previous lectures, and then we'll talk about, in brief, very brief, about unsupervised learning algorithms, and then we'll have future lectures where we'll be talking about the details of these algorithms. Okay, so machine learning is basically collection of methods or algorithms which are used to make computers understand patterns in the data without explicit programming. So, for example, these methods enable machines to improve with experience. So, if we see that machine learning is a black box, let's say this is the box, and we are feeding the data, and we are getting the understanding of the data. Okay, so that means we are teaching computers to understand the data. So for example, in the computer vision tasks, we are teaching computers to understand image and video data. In NLP tasks and natural language processing tasks, we are teaching the computer to understand text and speech data. So examples of supervised and unsupervised learning are that, like, so in the supervised learning, what we do is we have the data with associated labels or annotations or the ground truth, and the computer actually makes a pattern using the supervised learning algorithm, and it learns what this input data is, and whenever a new sample is coming, this learning is leveraged, and the prediction is made what kind of category this new sample belongs to. In unsupervised learning, we have the data, but we don't have the labels. So the unsupervised learning algorithm actually makes the different categories based on the some features. For example, like the appearance features, the color and the structure can be used to group the similar items together. So this is an example of clustering, and so this is how the unsupervised learning is done. Another is the reinforcement learning, where there is a robot which actually tries to learn to select actions when there is no data available. So for example, here the robot is coming to the fire, is going to the fire directly, and it is receiving a reward, let's say the penalty, and then it says that, okay, this is a bad action, I should avoid it next time. It will update its learning, and it will iterate this for all the hit and trials, and then the goal is to actually learn the right sequence of actions. So for example, going to the tap, fill the bucket, and throw the water in bucket to the fire. Okay, so this is what it should learn. Okay, so when we don't have any data, then reinforcement learning is what we do. Okay, so if we see in supervised learning, we are learning from the data with the labels xi and yi. Xi uh, is the is the data or the features of ith sample, and yi is the associated label or annotation of the ith sample when the data set has n samples. In this unsupervised learning, we are learning from the data without any label. In unsupervised learning, we don't even have the data. We are learning from interactions with the environment. So this interaction or the experience is actually containing these four tuples: the current state of the environment, the action taken by the actor or the agent, and then the reward received from the environment. Okay. So this could be both reinforcement and could be both supervised and unsupervised. So for example, this data we can collect a priori, and then we can use this data set as a learning strategy. Okay. So that means our algorithm can be used and can be trained on this particular data. Okay, so then that way, like, we are leveraging the existing data, but when the data set is not available, we are doing the interaction and collecting this data. It is primarily used for two tasks. One is the prediction, predicting the next state, or the behavior, predicting the best action on the particular state. Okay, so we'll see about these things as well. Okay, the commonly like approaches in supervised learning are the regression and classification. We have seen in the previous lecture. I think all the details of the individual algorithm we will be seeing in the coming lectures. In unsupervised learning, we have clustering and dimensionality reduction. Today we'll see if very brief about these two, and then reinforcement learning, value-based algorithm, policy-based algorithm, and the tree-based algorithms are there. We'll also be seeing these in the coming slides. Okay, so I'm showing you this slide from last two lectures, but this is very important. So in any of the supervised or unsupervised algorithm, we do the data set splitting. Let's say this is the whole data set we have. We split it into training and testing data set. And the training data set is further considered into training and the validation set. In the training data set, we actually train our machine learning algorithm, the unsupervised learning algorithm as well. For example, we'll make the clusters. We will evaluate if the clusters are proper or not. Using the validation set, we do some evaluation of fine tuning. And so on. Okay, so then when the final model is ready, we report the final performance on the testing set. Okay, so this is how the splitting and the model training and testing works. So unsupervised learning is a type of machine learning algorithm where the model learns patterns from the unlabeled data. When the labels are not available, unlike supervised learning, there are no predefined labels or outputs. So the key idea here is that the algorithm tries to infer natural structure present in a dataset by finding hidden patterns of the clusters. Common applications are the clustering, group similar data points together, dimensional reduction, reducing the point number of features while preserving important information, and anomaly detection, identifying the rare events or outliers in the data. So we have unsupervised learning process where we do the data collection first, gather a data set where the relationships or categories are not predefined. We do the model training. The algorithm explores the data to uncover patterns, grouping the relationships. So basically, the first is the data collection. We do the model training and then the model evaluation. Okay, we'll be seeing like what are the evaluation metrics are available for the clustering-based approaches to assess the effectiveness of the model that we have trained. Common unsupervised learning algorithms are: one is the clustering based, where we group the data points into clusters, where points in the same cluster are more similar to each other than those in the other clusters. So the commonly used algorithms are k-means clustering, deep-scan density-based spatial clustering, the spectral clustering, and so on. There are so many clustering-based algorithms. Hierarchical clustering is also there, and other clusterings are also there. Dimensional reduction reduce the number of features in a dataset while maintaining the essence of the dataset. Okay, so for example, principal component analysis, TSN, autoencoders, and so on. We'll be talking about these in the coming slides. Anomaly detection identify data points that do not fit the general pattern of the dataset. Okay, and so for example, here algorithms used are one class SVM, isolation forest, and so on. Okay, so I will be talking about each of these algorithms in detail. I'm just giving you a gist of like what kind of algorithms are available and what we do in the unsupervised learning, and maybe I will be using some board to actually explain all these algorithms. I will be giving you the details of these and so on. Okay, and we'll see. Okay. Okay, so example, if we see, so for example, what are the real world applications? So for example, social network analysis, let's say these are all the people who are connected with each other, and we want to see like who are belonging to the same group, right? So for example, they share the similar features, these guys share the similar features, these guys share the similar features. Similarly, like, so the same application could be for market segmentation. So for example, who all are interested in the product one, who all are interested in the product two, who all are interested in something else, right? So some other service that the company can offer. Okay, so this market segmentation is also very important. These are seen based on the some features of the individuals. Maybe here in the social media, the features could be like what kind of posts you are liking, how much time you are spending, and what all groups you have followed, and all these things, right? And here also, like this, the features are the based on the interest of the individuals. To evaluate the clustering or this unsupervised learning algorithms, I think it is only specific to the clustering only, where we see like how good clusters have been made. So one is the Siloth score, where we measure how similar a data point is to its other cluster compared to other clusters. So basically, like how a data point in its own cluster is similar to other points in the cluster as compared to the other cluster, right? Higher the score indicates well separated clusters. Elbow method is there for k-means clustering, where we use to determine the optimal number of clusters by plotting the variance explained as a function of the number of clusters. Okay, so this is actually used to see how many number of clusters we can make. Davis-Boolean index, which evaluates how compact or well separated clusters are. Lower values indicate better clustering. Okay, so these are the evaluation metrics. These are commonly used in clustering, and we'll see more about this when we will be talking about algorithm. Sorry, we'll be talking about the details of this algorithm clustering. Okay, so the real world applications of were only the introduction based we'll be talking about only the introduction of ML, supervised learning, and supervised learning. But in the coming lectures, we'll be doing more prompt engineering, reinforcement learning, where we will also be doing the coding. So maybe from the next lectures we'll be doing the coding as well, and so you guys can attend these lectures along with your laptop, so that you can see like how to do the prompt engineering, how to do the reinforcement learning, how to do clustering, like whatever lectures we'll be talking, those will be with the coding. And I would like suggest you to be with your laptop. You can try with me and all those things. Okay, and one more thing is, let's say if you want me to take any specific lecture, let's say other than prompt engineering, reinforcement learning, you can comment on this video, and then I will try to give that lecture. Okay, so thank you for attending this lecture, and join this AI club. Our mentors will be there to help you, and let's just do the networking in the community, and then uh, we will be seeing like how is it that we can help you start with AI. Okay, thank you. You can connect with me like through my webpage, and then we'll see like how to go ahead. Okay, so join our community. I think that is what I can say. And we are posting all the details on our WhatsApp channel. We will be start soon. We will soon be starting the Python lectures. Why I'm only talking about the introduction, so that other students who are very beginner, they can start with the Python. They can grasp the concepts, and then we'll be talking about each algorithm one by one. Okay, so let's just see. Okay, thank you, and let's see you in the next lecture.